everywhere you look in tech right now,
Yeah.
it's all about AI agents.
Yeah, definitely.
They seem to have just sprung up, promising to change, everything. But let's try and cut through the noise here.
Good idea.
What are they really, and maybe more importantly, why should you, someone just trying to keep up with tech trends without getting totally swamped, actually care?
That's exactly what we're diving into today. Let's try to put the hype aside for a bit.
Okay.
We're going to break down what AI agents actually are, how they function, where they're already making a difference across industries,
Right.
and also what things you should probably be thinking about as this tech keeps growing.
And we've got some solid sources for this, yeah.
We do. We're pulling from a really interesting recent survey on LLM-based agents. It's on ArcSiv if you want the deep details, plus insights from places like Hatchworks AI, Markovate, and a really clear YouTube video from Grace Loom.
Great. So our mission today is pretty straightforward then. Well, we want to give you a clear, simple understanding of these AI agents.
Exactly.
Not just a definition, but what they can do, the impact they're having, all aimed at you, someone who wants to be informed but maybe doesn't need, all the super technical jargon.
Perfect.
Okay, so let's start at the beginning. What exactly are we talking about when we say AI agent?
Okay, so at its core, an AI agent is basically a system that can operate on its own.
Independently.
Right. Think of it as something that can perceive its environment, so it sees what's going on, it makes decisions based on that, and then it takes actions, all to achieve some specific goal.
And the key is no constant human hand-holding.
Precisely. It does this without needing explicit step-by-step instructions for every single action. That autonomy is the really crucial part. Both Hatchworks and the ArcSiv paper really hammer this home.
Autonomous.
Got it.
So it has its own kind of engine. What actually makes it tick?
Yeah, you can think of its engine or maybe its brain as having a few core parts. First, there's the model itself.
Okay.
Often this is a large language model, an LLM, or sometimes several models working together.
Right, the LLMs we hear so much about.
Exactly. And they use these reasoning frameworks. Things like React, which is kind of like thinking then acting, or chain of thought.
Where it sort of talks itself through the problem.
Yeah, basically explaining its logic step by step. The ArcSiv survey mentions how these LLMs use their massive training data to get that sort of human-like intelligence.
And these models, they can be general purpose or specific?
Both. They can be general or fine-tuned for specific tasks, or even handle multiple types of info, like text and images that's multimodal.
Okay, so the model's the brain. What else is in this agent?
Well, next you've got what's often called the orchestration layer.
Orchestration. Like a conductor.
Kind of. Think of it as the manager for the whole operation. It governs the agent's cycle, getting information in, letting the model reason, and then figuring out the next action.
So it manages the workflow, takes the brain's plan, and makes it happen.
Pretty much. It ensures the steps happen in the right sequence.
I see. So the model decides what to do. The orchestrator manages how it gets done. But how does it actually do stuff? In the real world, I mean.
Yeah.
It can't just think things into existence.
Right, exactly. That's where tools come in. Hatchworks points this out clearly. LLMs are great with language, but they can't, directly book a flight or check a database.
Okay.
Tools are the bridge. They let the agent take action using things like APIs.
APIs, like the way different software talks to each other.
Precisely. Think of an API as a messenger the agent can send out to fetch data or tell another system to do something, like, hey, go get me the current weather.
So the model decides, I need the weather, and the tool uses an API to go get it.
You got it. And the ArcSiv survey talks a lot about these external tools, APIs, databases, even other AI models the agent can use. They give examples like Hugging GPT, using models from Hugging Face, or WebGPT for searching the web.
That makes a lot more sense. It's not just thinking. It's thinking and then acting via these tools. Now, I've heard there are different types of agents.
Yeah, there are a few distinctions. One key one is reactive versus proactive.
Okay.
Reactive agents, well, they just react to whatever input they get right now.
Simple stimulus response.
Kind of, yeah.
Yeah.
Proactive agents, though, they try to anticipate future needs. They adapt based on goals, not just the immediate input.
Interesting. So one is looking back, the other's trying to look ahead.
Just to put it that way.
What about working together? Can you have multiple agents?
Absolutely. That's the single agent versus multi-agent system idea. An agent can work alone. But for really complex stuff, you might have a whole team of agents collaborating. The Arstov paper mentions this, like, different agents playing different roles in software development in a system called ChatDev.
Like a little AI software company.
Something like that. Hatchworks also mentions this idea of agents working together on complex problems.
Okay, so we've got the basic structure. How does one of these agents actually work day to day? What's the cycle?
It's generally a continuous loop. First step is perception.
Seeing the world.
Or sensing it, yeah. Gathering information. Could be sensors on a car, text from a user chat, real-time data feeds. You name it.
Like a customer service bot reading my typed question.
Exactly that. Or a drone's camera feeding it images.
Okay, so it takes in the info. Then what?
Then comes the analysis and decision-making. This is the LLM brain doing its thing.
Right.
It processes the input using its knowledge and those reasoning abilities we talked about. The ArcSIF paper mentions different planning methods, some step-by-step, some that learn and adjust.
Like the chain of thought or tree of thoughts.
Exactly. Exploring different paths before choosing the best action.
So it's really thinking, analyzing, planning, not just instantly reacting.
Right. It's evaluating options.
And the final step in the loop.
Action. Taking the decision and turning it into something concrete.
Using the tools.
Often, yes. Making that API call, updating a database, sending a message, or sometimes using its internal capabilities like generating text for reply or recalling stored information. The action space, as the paper calls it, is the set of all things it can do.
Perceive, analyze, act.
Got it. Okay, the big question then. Why? Why are businesses getting excited? What are the real advantages here?
Well, Hatchworks lays out some pretty big ones. First, efficiency. Agents can just handle way more tasks, often much faster than people.
Okay, speed and scale.
Which leads to better customer satisfaction. Sometimes think instant answers about your flight status, not waiting on hold.
That's always nice.
Plus, 24/7 availability. IT help desks, e-commerce support. They don't need sleep.
True.
And scalability. Think peak shopping season, an agent can handle a massive surge in queries without blinking. And finally, insights. They can analyze data to spot trends, find product defects, suggest financial moves, things like that.
What are definitely major benefits. Can we get more specific? Where are we actually seeing these agents used today? Like real examples?
Oh, absolutely.
Yeah.
Markovate gives a great rundown across sectors,
Yeah.
banking and finance, for instance.
They're using them for fraud detection. Big banks like JP Chase, HSBC are on this. Also automated financial advice, speeding up loan processing. Wells Fargo is doing work there, handling transaction disputes. MasterCard's looking into that.
Makes sense for finance. Lots of data, clear rules sometimes. What else?
Healthcare is another big one. Analyzing medical data, potentially improving diagnostic accuracy. Google Health has projects there.
Wow.
Virtual health assistants, personalized treatment plans, even helping with drug discovery or processing claims.
Okay, that's impactful. What about, say, retail?
Retail's use them for more personalized shopping experiences. You know, recommendations tailored just for you. Also inventory management, dynamic pricing.
So the price might change based on demand automatically.
Could be, yeah. Or special offers just for you. Manufacturing is another area forecasting demand. Predictive maintenance, so machines don't break down unexpectedly.
Preventing downtime.
Exactly. Quality control, optimizing production schedules, even things like social media management agents, creating posts, engaging users, analyzing sentiment.
So they can tell if people are happy or angry about a brand.
Yeah, and optimize ads based on that. Travel and hospitality too, personalized recommendations, customer support, scheduling maintenance, making operations smoother.
It really feels like they're kind of everywhere, or soon will be. Any surprising ones?
Maybe legal services? Agents helping with research like co-counsel, analyzing contracts, predicting case outcomes. LexisNexis is exploring that, even managing client interactions.
Interesting.
IT departments use them for troubleshooting. Insurance uses them for claims processing, fraud detection, policy review, 24/7 service. It's a long list.
Okay, I get the picture. And you mentioned autonomous systems earlier.
Right, that's a huge category in itself. Self-driving cars, Tesla, Waymo drones,
Right.
robotics, all heavily reliant on AI agents. And the ArcSpeed paper adds more, like in software engineering, automating coding, testing, documentation with tools like ChatDev or MetaGPT, even social science research and natural science discovery.
Wow. Okay, the why is clear. Loads of applications. But what about the when? When should a business or a person think, okay, this problem needs an agent versus, say, just a regular chatbot or some other AI?
That's a great question. Grace Lalong's video gives a really practical framework for this. She says it boils down to a few things.
Like what?
First, Problem complexity. Is it simple? One step. Or does it need multiple steps? Maybe some creativity, complex decisions.
Okay, complexity matter.
Second, control versus autonomy. How much are you willing to let the AI run on its own? More autonomy means more power, but maybe more risk if it goes wrong.
Right, the trade-off.
And that ties into the third point, risk tolerance. How bad is it if the agent messes up this particular task?
Makes sense. Complexity, control, risk.
Yeah,
And Ling had those 4 approaches, right?
exactly. She laid out 4 levels.
Yo.
1, the basic AI chatbot, good for simple Q&A, high human involvement. 2, AI workflows or assisted workflows here. It helps with more complex tasks, but you're still guiding it. 3, fully automated AI workflows. These handle structured, lower risk tasks with predictable steps. Minimal human oversight needed once set up.
Set it and forget it, almost.
Kind of. And then 4, AI agents or agentic workflows. These are for the really complex problems where you need that high autonomy and decision-making power.
And she had that example. Generating a report.
Yeah, the monthly traffic report. It illustrated it perfectly. A chatbot can't access the data, can't do it.
Right.
Assisted workflow. You manually pull the data, then maybe use AI to help write the summary.
Okay.
Automated workflow. Predefined steps. Connect to analytics, pull specific metrics, put them in a template, save it. Very structured.
Got
But the AI agent, you just say, generate the monthly traffic report. And it figures out, okay, I need to use the Google Analytics tool, maybe a spreadsheet tool, maybe a document tool. It selects the tools, runs the analysis, makes decisions on how to present it, and builds the report autonomously.
That really clarifies the difference. It's about choosing the right tool or level of automation for the job based on those factors. Complexity, control, risk.
Exactly.
Now, this all sounds incredibly powerful, but there have to be challenges, right? Things to watch out for.
Oh, absolutely. Both the survey and the reworked article point out several key considerations.
Yes.
Well, one is role-playing. LLMs are good, but they might struggle with really nuanced or totally new roles you ask them to take on.
Okay.
Human alignment is a big one. Making sure these autonomous agents actually act in ways that align with our diverse human values. That's tricky.
Yeah, I can see that being complex.
Prompt robustness is another. How sensitive are they to tiny changes in how you ask them to do something? Especially in complex agent setups, a small wording change can potentially lead to very different outcomes.
So brittleness potentially? What else?
The survey mentions the knowledge boundary issue. Sometimes in simulations, the AI might know more than a human participant realistically would, which could skew results.
Ah, interesting point.
And then there's trust and explainability. Reworked really emphasizes this. We need to understand why an agent did what it did. Black boxes aren't ideal when they're making important decisions.
Definitely need that transparency.
And of course, security and privacy. Hugely important when agents handle sensitive data. We need strong safeguards.
Security, privacy, transparency, all crucial. Any other hurdles?
Yeah, Reworked also brings up management and orchestration, especially at scale. How do you effectively manage and monitor potentially hundreds or thousands of agents?
Good point. Logistic.
And human-agent collaboration. Making that interaction smooth and effective is key. Plus, cost and resource management, keeping track of the actual financial impact of running all these agents.
Well, lots of practical challenges still being worked on. Looking ahead then, where is this all going? What are the future trends?
Well, expect even tighter integration with other tech, like
Right.
IoT devices or maybe blockchain. We'll likely see more sophisticated platforms specifically designed for managing agents, and a big focus will be on that human-AI collaboration, making it seamless. Hatchworks even talks about the potential for agentic organizations.
Agentic organizations.
Yeah.
Wow, where agents are just part of the operational fabric.
Pretty much, yeah. Deeply integrated.
Okay, that's definitely something to think about. If someone listening is intrigued and wants to dig deeper, maybe even experiment a bit, where should they look?
Hatchworks mentioned a few starting points. There's agent.ai, which is like a marketplace. Crew AI is a platform for building agents. You can find open source frameworks using Crew AI too. LangChain has tons of resources for developers. And there's even a GitHub repo focused on browser-based agents.
Great, some places to explore.
Yeah.
So, wrapping this up, what's the single biggest takeaway from our deep dive today?
I think the key thing is that AI agents are a really significant evolution. They're moving beyond just processing info to actually acting autonomously to solve problems.
Right, it's a step change.
Yeah, and that offers huge potential across so many fields, but it also brings new challenges, technical, ethical, practical, that we need to navigate carefully.
And for you, the listener, what's the main thing to maybe ponder after hearing all this?
I'd say think about your own world. How could AI agents impact your industry, your job, your interests? Where might that balance between automation, control, and risk fall for the problems you care about?
Good questions.
This deep dive is really just scratching the surface. Definitely check out the sources if you're curious. Keep learning because this space is moving incredibly fast. And maybe the final thought to leave you with is, as these agents get more capable, how does that fundamentally change work itself and that relationship between humans and AI?
A big question indeed. Definitely something to think about.